All right, so our topic for this project is building science and its current effects and what the future may look like. So, for some background, buildings are a big part of our lives. They dictate everything we do, whether it be where we live, where we work, where we go to school, and many more. Buildings account for 40% of energy consumption in the US, 54% of the natural gas usage, 70% electricity, and 33% of greenhouse gas emissions. Now, as you can see on the figure on the right, buildings emit 6 gigatons of CO2 per year. This is more than any other costs to reduce the emissions compared to every other sector. So this is the perfect challenge or perfect opportunity to reduce emissions, to reduce climate change. The scenario that we're focusing on for this project is glass skyscrapers. Last year, the New York mayor said glass skyscrapers have no place in our city or our earth anymore. And if you look at statistics, 66% of greenhouse gases in New York City come from buildings. And with glass buildings, you need more air conditioning, which leads to 60% higher CO2 emissions than a normal mechanical ventilation system. There's also more glare with glass buildings, which leads to uncomfort in working conditions in some offices. And also, although glass buildings are more aesthetically pleasing to some, the manufacturing cost of the glass facade is 3 to 5 times more than the brick facade. Now, to look at the relation to heat transfer, a window can be represented as a thermal circuit in series, as shown on the top left picture. The heat rate through the window from the equation on the bottom is the change in temperature on either side of the window or the wall divided by the sum of the thermal resistances. Thermal conductivity, the higher it is, the lower the thermal resistances, and glass has a relatively high thermal conductivity compared to air, which is in between the two glass panes. So adding more pockets of air would increase your total thermal resistances, making the heat rate much lower than just a single pane or double pane window. However, fiberglass, which is a common insulator, a wall has, and there's also contact resistances between the different layers, making the thermal resistance much higher in a wall rather than in a window. And with higher thermal resistances, you have lower heat transfer rate, which then you can have less air conditioning, which leads to less emissions and less climate change.
So you can look at what the New York City mayor said, and you can say in one sense he's right. If you got rid of all the glass buildings, it would probably be more efficient and that sort of things, but it goes much deeper than that. And one idea comes from the architect Bjarke Ingels and his idea of hedonistic sustainability. And what he says is that if you want to make strides in climate change, you have to cater to people's wants and people's comfortability. So you can do this in building design by integrating like many sustainable concepts into the architecture. So that means if people want glass buildings, then you need to make the glass more efficient, like Josh was talking about with multiple panes. But you can also look at how a building like acts in society, so it's a function of society. And a good example is the two on the right. So the top right is a power plant in Copenhagen called Copenhill, and they took a plant that burned fossil fuels and was an eyesore to the whole city, and changed it into a building that burns the trash of the city, and also has a ski resort slash hiking on the roof of the building, and has climbing wall on the side, and is just overall a place where people can appreciate the outdoors, and is now a building that gets rid of clean air. And on the bottom is a plan they came up with to integrate different aspects of public life. So they said, supermarkets, you know, we need them, but they produce the most excess heat of any public building, and that's because all the refrigeration and freezing required. So if they took that heat and they combined it with the need of heat from a public pool, and then you can get a system that is much more efficient with its power. And additionally, you can add on sustainable ideas to existing buildings. So that includes solar panels or wind energy and everything in between, and just add that to existing buildings. The next category is what I call passive solutions versus the last one, which is active. And that comes from organizations like LEED and ASHRAE, which take measures to establish guidelines for building codes and in particular sustainable buildings. So the figure on the top right is the rating systems of LEED and how you can achieve different ratings through making increasing water efficiency or any number of different measures. And then the other option is lawmaking and government incentives. And a good example of this is the city of Pittsburgh, which has introduced a number of like financial incentives for building developers and owners to steer them in the right direction to making things more efficient. So two good examples of this are one of them is Hudson Yards in New York City, which was a whole neighborhood development. And this is interesting because they had an entire blank slate to work with. So what they did is they built a neighborhood from the ground up that operates off of its own power grid, which supports all the commercial, residential, and public spaces within the neighborhood. And through a number of different measures, they achieved the LEED Gold certification. And the other one is a multi-purpose urban space called Nightingale 1, which is in Brunswick, Australia. And what they did is they focused on the communal aspects of living to promote sustainability. So that means they combined restaurants and commercial spaces and residential spaces all into this one building, which has like a public garden on the top that everybody can use to grow things. And they use sustainable resources to build the building. And through a number of different active solutions, including solar panels and all that stuff, they are 100% free of fossil fuels for the entire building operation. So I think these examples do a really good job of showing that you don't need to get rid of all glass buildings, like the mayor was saying, in order to achieve sustainability. What you can do is you can come up with different design solutions or engineering solutions through heat transfer and all that stuff in order to make the world a more sustainable place. And here are our references. All right.